All right, Brandon Clayton, the Algebra Guy here. Today, as you see on your screen, I want to talk to you about simplifying complex fractions. Look at these fractions on this screen. We got 6/7 divided by 3, 3/4 divided by 5/8, x over 2 divided by 5/6. Can you handle those? Well, if you can, you don't need this video. But if you're struggling just in the least bit, stay tuned. I want to show you how we can take care of those pretty easily. So the two questions I want to answer: what is a complex fraction, and how do we divide complex fractions? So this be pretty quick and straightforward. A complex fraction is a fraction in which the numerator and or the denominator contains a fraction. It looks really funky because you're used to having just something that looks more like this down here, 3/4 divided by 5/8. But what if you had this situation, 3/4 over 5/8? So to simplify that fraction, you can see what we did. We just took and rewrote it. 3/4 divided by, don't forget this line right here does mean division. 3/4, so we can rewrite it in a way that we feel more comfortable writing it, and that way we can work it out. And that's exactly what we're about to do. So let's get to that question. So let's practice this. If I have it this way, what do I do? So convert the mixed number to an improper fraction. Follow the rules for multiplication. So we're going to convert, well, we don't have a mixed number here, but we're going to convert this complex fraction so that it's a linear fraction that looks a lot easier to deal with. So 3/4 divided by 5/8, just like we saw a second ago. Now from here, it should be pretty simple. That's really the only new move that you should be acquiring at this point, because everything else we've talked about. So dealing with division, we're just going to take 3/4, and then we change this to multiplication and do the reciprocal. And they want the simplified answer, so I'm going to go ahead and prepare for that by putting my numbers 3 times 8 into all prime numbers. So 8 is going to be 2 times 2 times 2. And if you can't put them in all prime, it doesn't matter. It's not that important. Like, you have to do it in order to get the right answer. It just makes it a little bit faster sometimes when you're crossing everything out. So just break it down into some factors that you know is true. It's like 4, I know is 2 times 2. And then I got times 5. Looking at the numerator and the denominator, I know I can cross out one of these 2's and cross out another 2. I'm left with what's remaining, which is 3 times 2 up top, 6, and a 5 on the bottom. And there's my answer. 6 over 5. If I wanted a mixed number, it'll be 1 and 1/5. 1 over 1 and 1/5, because 6 divided by 5 gives me 1. 1 times 5 is 5. 6 minus 5 is 1. So that's 1 and 1/5. All right, what about this guy here? So same thing. The reason that this one can be problematic is because you have a whole number that you're dividing by. So how do you do that one? So to divide by this whole number, just remember that we can change whole numbers into fractions pretty easily, right? By doing what? Dividing by 1. So just putting it over 1, it's the same thing. So when I rewrite this, I'm going to rewrite -6 over 7 divided by, because that's my divided by sign right here, 3 over 1. And now it's easy because these are the problems I'm familiar with. I just know to go ahead and change, keep my first term just how it is, then change the division to multiplication and flip. Instead of 3 over 1, which is 3, we're going to have 1/3. Now it becomes really easy because all I do is just multiply straight across. -6 and 7 times 3, 21. Now I notice I didn't pull out my numbers this time, so now I still have to simplify it by breaking it down. So I have a negative, this is going to be a negative answer, 3 times 2. And down here I have 3 times 7. 2, I'm sorry, not 2, but 3 can cancel out, leaving us with -2 over 7. Voila, that is it. That's how you simplify it. And I know I at least got one more. Let's see. Yep, good. So we have a one with variables. Please don't be intimidated by the fact that you have variables. They're just representations of some number. They vary depending on what problem it is. That's why they call variables. But follow the same process. In higher mathematics, the higher you go, the mathematics is curious if you know how the structures work, if you know how math works, not just if you can solve an answer and get some clean 2 or 4.3, you know, but do you know how it works? And we do. We know that when we have this set up, we can rewrite this to say x over 2 divided by xy over 6. It says that right here. And sometimes if I'm stuck and I don't know where to go, I at least do the minimum of what I know. And when I do that, sometimes seeing what I wrote sparks me to get to the next level. So now when I see this, I'm like, okay, yeah, I remember this setup. You just keep your first term, x over 2, and you change your division to multiplication. And then you do the reciprocal. That multiplication, that's why we don't use x, because that looks just like one of my variables. So we use a dot or a parenthesis. So we're going to do reciprocal. And now we're going to multiply straight across. And I'm going to pull out all the factors, separate them so I can see if there's anything else that can be taken out. So when I look on top and bottom, I ask myself if anything can be canceled out. And I do see an x. I'm going to use a different color. X can go, this x can go. I don't see anything else that I can take out. Actually, yes, I do, because this 6 has a 3 times 2. So those 2's can come out. And that's why I try to take it down to the prime number. I forgot about that. I almost missed that. So now we end up at top left with a 3, and on bottom just with a y. So that'd be 3 over y. And I like to double check, make sure I didn't miss any signs like the negatives, and because those are easy to miss, but looks like I got it all. So 3 over y is my answer. I believe this is our last one. Pause it here and see if you can work this yourself without my help. All right, so the first thing I'm going to do is rewrite this in a way that I can see clearly what I'm supposed to be doing. It's supposed to be 2 3/4 divided by 1/8. First thing I do is convert these mixed numbers to improper fractions. So 2 times 4 is 8, plus 3 is 11. It's going to be 11 over 4. Change this division to multiplication and reciprocate the 1 over 8 to 8 over 1. All right, now I can multiply straight across. 11 times 8 gives me 88. All right, no, I don't want to do that. I want to break it down. So 11 times 2 times 2 times 2. There, I make that easy. And 4 goes into 2 times 2. And now I can see what's going on. That I'm going to cancel out those 2's on top. 1, 1, and this one and this one. Leaving us 11 times 2, which is 22. And that's it. So just 22. So 88, 11 times 8 is 88. 4 times 1 is 4. So 88 divided by 4 would have gave us 22. You could also have done it that way. And that does it for us today. So what did we accomplish? Did we do what we were set after to do? Answering the question, what is a complex fraction and how do we divide complex fractions? Yes, we answered both of those questions. Thank you for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next class.